Hey guys, in this video, we are going to talk about how to solve linear equations, but with applications. So meaning real life application problems, word problems, the dreaded word problems. What I'm going to show you is just how to do an initial setup for these first few examples. This note sheet is posted in Schoology, so you will want to use this as a reference because I am going to ask you to do a few of the problems on your own. Just make sure you take a look at the 1.3 note sheet. It says 1.3 part 2. That's what I called it in Schoology. So just make sure you have that document open so that you can take a look at some of these problems as well. So the first question says the table shows the rates of two taxi services. How many miles do you need to travel for taxi 2 for it to be a better deal? Okay, so if you look at taxi 1, there's an initial $2.75 fee, which is pretty typical when you get into a taxi. And then it's $2 per mile. Okay, taxi 2 has an initial fee of $4.50 that you pay, but then the rate per mile is a little bit less. It's $1.75 instead of $2. So eventually, taxi 2 will be a better deal. But if you're just going to go maybe a shorter distance, maybe taxi 1 is a better deal. What we're going to figure out is when it's going to be the best point to switch to use taxi 2, like how many miles you would need to travel. Okay, so what we're going to do is set up an equation. And anytime I set up a linear equation, you want to think of two things. You want to think of your rate. And whatever your rate is, that's what you're going to multiply by your variable. So I'm going to call this V for variable. Then you're going to add in your initial, or like your flat fee that you would pay. And that's going to be your total. So this is kind of the setup that I'm going to use for all linear equations problems. Okay. So our rate, let's just talk about taxi 1. We have an initial fee and then a rate per mile. So, I mean, I know it says the word rate, but the word per is like a key word. Anytime you see per mile, per hour, per minute, that's going to give you a hint that that's the rate for your equation. So we're going to say for taxi 1, our rate is $2. And it's going to be $2 since it's per mile. That means we're going to multiply by our variable, which in this case, since it's per mile, our variable is going to be m per mile. So it's going to be $2 times m plus our initial fee, or that's kind of like a flat fee that you would pay. So sometimes, like if you order something online, you pay the cost and then there's like a flat fee shipping that you have to pay one time. So this is always going to be something that you pay one time. So our initial fee or our flat fee here is the first thing that we pay when we just get into the taxi at $2.75. Equals our total. Well, we don't know what our total is. What we want to do is figure out when taxi 2 will be the same or taxi 2 will be a better deal. So we're going to set these two equations equal to each other. So here's my taxi 1 equation, and now I'm going to make the same equation for taxi 2. Okay, so I'm going to look again. I'm going to look for my rate. So my rate for taxi 2 is $1.75, and that's per mile. So we do times m. So we're using the same variable because we're talking about miles here. And then plus our initial flat fee or our initial fee, which is the $4.50. So plus 4.50. So what we have done is we have set up just a simple linear equation like we've been solving. So we're going to go ahead and solve for m here. So in order to solve, remember we have our first step is distribute. Well, we don't have parentheses here, so we're good. Second step is to combine like terms. Well, on the left, these are not like terms. On the right, these are not like terms, so there's nothing to do there. And then that step 3 that we talked about was getting the variable all to one side. So I always look at my variables. I have m's on both sides, so I'm going to move one of them to the other side. So I always like to do right to left. So I'm going to subtract 1.75 m on both sides. And remember, we always line it up with our like terms. So that's going to go away. And $2 minus $1.75 is just 25 cents or 0.25 m. And then we're going to keep this 275 here. And we're going to keep the 450. Okay. And then we're going to start going through our order of operations or PEMDAS backwards. So we're going to get rid of our adding or subtracting. So around my variable, I'm adding 275. So I'm going to subtract 275 on both sides. If I do it on the left, I have to do it on the right. So these are going to go away. I'm going to be left with 0.25 M equals, and then 450 minus 275, sorry, gives me 175. Okay, and then our last step is to undo multiplication or division. So we have times 0.25 here. So we're going to divide by 0.25 on both sides. So again, I'm just typing these things in my calculator. I don't expect you to do these all by hand. So our 0.25 divided by 0.25 goes away, gives me 1 M or just M. And 1.75 divided by 0.25, notice that I'm dividing by a decimal that's really small. It's almost 1 or almost 0, not almost 1, it's less than 1. That's going to make our answer actually get bigger. So 1.75 divided by 0.25 actually turns out to be 7. So we get M equals 7. So what that means is at 7 miles, if both taxis drive you 7 miles, it's going to be the same price for both. But if you need to go farther than 7 miles, it's going to be worth taking taxi 2 because it does have the cheaper rate. But like say I only need to get home, well, I live 3 miles from here. Well, I would take taxi 1 then because it would be cheaper. Okay. What I want you guys to do is take a look at questions 2 and 3. These are very, very similar. One is about music service, like a Spotify type thing or something like that. And the other is about going bowling at 2 different places, and we're going to compare them. So I want you to try to set up your equations for that and just see if you can come up with the correct equation. I don't need you to solve them right now. We're just going to set them up. So go ahead, pause the video and try to do that. And then when you finish, come back and just check your equations. I'm not going to work through solving them. I just want to see if you can set them up. So for number 2, if you look, Cameron pays 95 cents per song. So again, because it says the word per there, that tells me it's going to be my rate. And per song, so I'm going to use S for my variable. So I said 0.95 S. And that's his current music service. There was no initial joining fee or flat fee or anything you had to pay there. So the left side of the equation is just 0.95 S. And then the right side of the equation is the new music download service. So it's 89 cents per song. So again, that's my rate, 0.89 S, because it's per song. And then the $12 joining fee, that is the one-time flat fee. This would be your equation for number 2. You can go ahead and solve that if you want and figure out how many songs you would have to download to make it worth switching. For the bowling problem, it says how many games is the total cost of bowling going to be equal? So when you go bowling, you pay per game and then you throw in a shoe rental or something like that. So if you look at the Family Bowling League, it's $4 for a game. And so that's $4 per game. So we're going to do $4 times however many games we play. And then the flat fee or the initial fee there would be the shoe rental, which is going to be $1. You only pay that one time when you bowl. You rent shoes once, but then you can play as many games as you want. So we want to know when that's going to be equal to the Night Owl Bowling. So that's $3.75 per game. So it'd be 3.75 G. And then that shoe rental is our flat fee or our initial fee. That's going to be at $2. So again, this would be the equation that you would set up for this problem, and then you would go ahead and solve. So if you want to, I would take a minute and see if you can solve these and come up with your answers. They should be nice, pretty whole number answers. So if you are not able to get those, please let me know in class and we can go over them. But I want to move on to the next type of question. So the setup's a little bit different for this one. You kind of have to pick apart the information and set it up yourself. And just by thinking through like how you would spend that money. So for question 4, it says Olivia ate at the same restaurant 4 times. Every visit, she ordered a salad and left a $1.50 tip. She spent $54 total. We want to figure out how much each salad would cost. So each visit, so she visited 4 times, she ordered a salad. Okay, so that means she had 4 salads. So because she had 4 salads, and salads is the price of the salads is what I'm trying to figure out, I'm going to do 4 times X. So it's $4 times, or I'm sorry, it's not $4, 4 times however much a salad costs. So 4 salads plus she left a $1.50 tip. So she left a $1.50 tip, but she did that each time. So it's going to be a $1.50 also times 4. And then that's going to be her total that she spent, which in this problem they give us was $54. So this one you kind of have to think through. She's spending money on 4 salads, so 4 times however much the salads cost, plus 4 times the $1.50 because she's tipping a $1.50 4 times. And when you tip, you're spending that money, so you have to add that into the cost. Okay, so this one is a little bit more simple of an equation. We have 4s plus 4 times a $1.50. That's going to give me $6 equals 54. If I subtract 6 on both sides, I'm just going to kind of do this real quick. I'm going to get 48. And then I would divide both sides by 4. So I would get S equals 12. So to answer the question, it says find the cost of each salad. So each salad costs $12. So go ahead and take a look at number 5. This one is a similar type of problem. However, you have to think about when you are like in this problem, in the last problem, we had a tip, so we added that into the cost. Here we're getting a discount, so we wouldn't add in a discount, you would subtract that out. So this is a very similar setup, but when you set up your equation, you want to think about, am I paying money when I get a discount, or am I taking that money away from my total? So you want to think about that when you set up your equation. So go ahead and set that up real quick, pause the video, and then come back and see if you got it correct. So hopefully you were able to set up question 5. So since 4 friends bought concert tickets, that means there were 4 tickets. So I did 4 times T because I don't know how much the ticket was. So 4 times however much the tickets cost. But then they get a $15 discount, and that's per ticket. So the $15 discount I subtracted right there. So you want to make sure you have a subtraction sign, because we're going to take 4 times however much the ticket costs, but then we're going to take $15 off of each ticket. So $15 off times 4. And then that would give us the total that they spent for, which was $312. So this is the cost of the ticket minus the discount, whereas question 4 was the price of the salad plus the tip. We were adding that in. So that's why for this one we subtract, because it says discount. So you could go ahead and simplify this and solve. You get 4t minus 60 equals 312, and I'm not going to talk you through the whole solving process, but I'm going to add 60 on both sides and divide by 4 on both sides, and I'm going to get t equals 93, which makes sense. The $93 concert ticket, that's a pretty normal price that you would pay, and then $15 off of that isn't too bad. So hopefully this was helpful in setting up some of these problems. We're going to continue to work on these all year long, setting up equations and solving. So go ahead and take a look at some of the homework problems and let me know if you have any questions.